It is a second lecture CE 638N. Let us start with this basic fundamental concept of consolidation and consolidation settlement. What do you mean by this consolidation? Now, let us say saturated soil it is acted by increase in stress. So, then soil skeleton undergoes deformation, or it is called strain. Now, come back to strain. Its cumulative effect of one is grain distortion, then plus particle rolling, then plus slipping of particles. So, then from here, because of this, so there will be reduction in void ratio, or we call volume change or pore fluid dissipated. Now, with this let us start with this consolidation and consolidation settlement. The concept of consolidation, now a soil consists of, if I take it 3-phase system, it is solid, it is liquid, it is air. With this 3-phase system, now if you say this saturated soil, if I apply increase in stress by means of application of external loaded or maybe other means, then what will happen? The soil skeleton changes or deform, or maybe the soil skeleton deformation occurs. How the soil skeleton deformation occurs? If you come back here, this soil skeleton deformation is called nothing but a strain. In geotechnical engineering, if I come back to strain, the physics behind it is cumulative effect of grain distortion. Now, grain distortion means the particles arranged or oriented in different size, different shape. Grain distortion means this grain size, grain will particularly disintegrate. That means what will happen? The particle breakage will occur. Because of particle breakage will occur, there is a distortion of these particles. That is number 1. Now, number 2, particle rolling. What happened? By externally applied stress, particles are like this. Once you apply this load, the particle starts rolling above the other particles. This, because of this rolling of these particles, again deformation will occur. Third part is your slipping of particles or solid particles. It may happen without rolling, the particle may slip, the particle may slip. So, once particle slips, then again the soil undergoes deformation. So, strain, if I make it summarize strain in geotechnical engineering, it is cumulative effect of grain distortion number 1. Second part is your particle rolling, that means particles roll above each other or maybe single particles rolls above the other particles. Then third is your slipping of particles. It may be one phenomenon or it may be two phenomena or it may be cumulative of 1, 2, 3. So, in that case you put it in a strain, its cumulative effect of grain distortion, particle rolling, slipping of particles. Now, what will happen? What is this physics behind it? What will happen? Because of this, there is a reduction in void ratio. Void ratio, because there is a reduction in void ratio, then what will happen? Volume change will occur. Once volume change will occur means these pore fluids, these fluids inside the soil will dissipate. That is called strain related to your consolidation. This is the complete definitions, and behind it once again because of your grain distortion, particle rolling and slipping of particles. If I define or definition, consolidation, it is time dependent, also it is elastoplastic deformation. Then before I define this consolidation, ask yourself these questions: what is the difference between compression and consolidations? In compression is a simple volume change without any time, that is called compression. In consolidation, if you say it is consolidation, this is a time dependent phenomenon, because this all these cumulative effect, grain distortion, particle rolling, slipping, it takes time. Over the period of time, then the reduction in void ratio will occur, then volume change. So, consolidation means the phenomenon is a time dependent and its behavior is elastoplastic deformation. Now, come back to what are the errors that we encounter during laboratory tests. Before I go for in details, let me write these points, then I can explain. Let me start with this, what kind of error or possible errors that may happen or may occur during our laboratory test. It may not truly reflect your field test, means in field conditions or in situ conditions. Let me start with this back. Let me start there. These are the 4 points. One is soil should be saturated, second is your coefficient of permeability, third is your change in temperature, fourth is your sample unloaded. Let me start with this back, then from bottom to top let me go. First part is your, say, let us say fourth, sample unloaded. Suppose in the case of we collect undisturbed sample in field, say at a distance h or at a distance z. So, where this sample has been, undisturbed sample has been collected. Before collection of undisturbed sample, now you ask these questions, what will happen? The moment you collect this sample below the ground, so it will lost pore pressure is lost, then second is your overburden, it is static water, static water table, pore pressure is lost, then overburden pressure is lost. The moment soil particles collected or maybe soil samples collected at distance h from the ground surface, before collection of the soil sample, if you look at here, these pressures acted in these 3 dimensions, one is vertical, other is your lateral. The moment you collect the sample, undisturbed sample, immediately it lost this overburden. So, we are starting with this point number 4, sample unloaded. That means, before unloading, suppose I collect a soil sample at a distance h from the ground surface, what will happen with the soil sample? This will be acted upon by overburden pressure, this gamma z, as well as confining pressure. The moment this soil sample has been taken out from the ground surface, what will happen? This overburden pressure gamma h it lost to bring to the laboratory. Then is there any, then the next question is there any static water table pore pressure? Yes, there is a static water table pore pressure, immediately it will lost. Both these cases will be lost. This will time, the moment you bring it to lab, from field to lab, it will take time. That gives an error, that gives an error. So, this is, I can say this is my first error. If I number it 1, 2, 3, 4, it is most important part of this error encountered in the laboratory test, you can put it. Now, come back to third point, third and second, these are same. If I say coefficient of permeability, you can assume that coefficient of permeability in the in situ condition, it is constant either x or y. The moment you take it out in the lab, the permeability, coefficient of permeability, it lost this coefficient of permeability. Another major part is temperature. At distance h in the ground, what is the temperature, soil temperature? Say 40 degree or say 30 degree. The moment you take out the soil from this ground surface and bring it to lab, immediately the temperature variation is there. If the temperature variation, from 10 to 30 degree, means arbitrarily say 10 to 30 degree, the result will be changing from this consolidation 30%. say. That means in the lab this change in temperature has to be applied, means it has to be applied considering in situ condition what is the temperature. Now coefficient of permeability, it is not true, coefficient of permeability is constant conditions, in situ means in the field condition, which is not true in case of lab. That means in laboratory large error may be encountered. Then first one is most important, that is your soil should be saturated. If soil is not saturated, what will happen? This where this consolidation means expulsion of water from the void space over the time, means it is a time dependent phenomena. If there is no water, there is how this change will occur? Volume change may occur because of your secondary consolidation, that means without water. So this soil, if it is saturated, you can find it out consolidation also partially saturated, there is no problem, you can do it, but the prime phenomena is soil should be saturated. Once it is saturated, if it is not if it is fully saturated, you bring it back to lab. In the lab soil has to be fully saturated before the consolidation test has to be performed. So these are the common errors it occurs, means there are the possible errors it may occur in the laboratory test. Before doing this consolidation test or maybe audiometer test in the laboratory, these errors should be taken into consideration, means these factors should be taken into consideration, so that this error can be nullified as far as possible. Now with this laboratory test, what are the things you are going to get? What is your output, means why you are doing this consolidation test in the laboratory? So first we will start with this consolidation characteristics. Compression index, coefficient of consolidation, now the basic means consolidation characteristics, if I say one is compression index, other is your coefficient of consolidation. These two parameters required particularly in consolidation, maybe in soil mechanics or maybe in foundation engineering design parameter you can say. Now what does it mean by means of CC? CC means compression index. CC means how much consolidation or settlement will occur, means how much consolidation or settlement will occur. That means if there is a ground surface, there is a soil, layer of soils are there, maybe the footing is there, apply a load, then CC means how much consolidation and how much settlement. Suppose if I say this is my layer 1, this is the layer 2. Now for this layer 1 with application of load say 2000 kilonewton this footing, this load is coming on this footing. So, that means with this load how much settlement it will occur, say maybe within 10 years, 20 years time, or maybe say as it is a time dependent, you can fix like a residential building we construct for say 50 years span, we ask it for 50 years. So, maybe 20 years, 30 year or 40 year, 50 year, with a time dependent you fix this time, how much consolidation or how much settlement will occur for this CC compression index. Now, come to next part is your coefficient of consolidation CV. The moment I say CV, it is how much and it is how long. Total how much settlement will occur, first part CC, CV is if the settlement will occur how long. If there is a settlement or there is a consolidation is there, then how long, 1 year, 2 year, 3 years, 6 months or maybe 10 year, 20 years. So, these two phenomena are primary means characteristics or maybe basic characteristics of this consolidation, which has been used particularly in design of foundations, the CC and CV we will discuss over this. Now, first we will go to this laboratory part, get this consolidation characteristics or maybe consolidations, this parameters C and CV, then we will start this, go one by one. Now, there are two consolidometer, two test apparatus are available. One is floating ring, other is your fixed ring. Now, if you come this to floating ring and fixed ring, in this case of floating ring, it's a, if you look at here, this is a floating ring diagram. A soil sample is fixed, soil sample is there. At the top there is a porous stone, at the bottom there is a porous stone. You can say this is top, this is bottom, or you can say this is top, this is bottom, depending upon that how you would decide it. So, porous stone has been put it and surcharge has been applied. Here it is dial gauge. It measures this deformation. Now, in this case what will happen, base porous stone, particularly if this is my base porous stone provides lateral drainage. That means, if I apply load here, the load has been applied, this porous stone is there, this is the porous stone, this load has been transferred from here to this porous stone to soil sample, then your this drainage of water has occur here at this base porous stone, means lateral drainage occur at the base porous stone, the compression will be occur by means of applying surcharge from the top porous stone, it will be occur. So, here drainage will be occur. Then compression, in this case compression will be takes place both at the top as well as bottom, that is why it is called floating ring. That means compression takes place from both faces of soil sample, this face also compress, this face also compress. If I say that this is my soil sample, so this compression will occur both faces, this face, if this is called top face and this is called base or bottom face, bottom face. So, this compression occurs both the faces, top and bottom of the soil sample. In case of fixed ring, what will happen, this ring is fixed at the base. So, it has been, this is my base, ring is fixed. So, piezometer has been attached, once load is applied here, because base is fixed. So, the drainage can occur only at the top porous stone, load applied. So, this is fixed, this is connected with this piezometer. So, once it is applied, because this is a piezometer, water is there. So, once it will apply, this flow starts from this top of this porous stones. So, this is the basic difference. If you look at this floating ring and fixed ring, this is as per the American Society of Testing Materials. This floating ring base porous stones provides lateral drainage. In case of fixed ring, drainage or drain through top porous stone. That means, in this case lateral drainage occur in case of base, in this case drainage occur in case of top porous stone. Then compression takes place, in this case both the faces, fixed ring compression takes place in case of only one face. So, this is the basic difference between floating ring and fixed ring type of things. So, what will happen, the moment you apply, what is the load increment you have to apply, how this test has been performed in the laboratory. That means, suppose you say you apply a load 25 kPa initially, for example increase in load, this is my delta P. What is the next step, how much load increment you are going to apply, In case of geotechnical engineering, if you look at here, if it is 25 kPa, then next step of load application will be 50, next will be your 100, it is just double 25, 50, 100, 200, 400, 800, 1600 like this. So, why now the question comes here in particularly this course or maybe in geotechnical engineering, why this load has been applied in the soil sample always double. Initially it is 25, next is your 50, next is your 100, next is your 200. You think this is for you, maybe read some books and tell me all geotechnical engineering, whether it is a direct shear test, whether it is a consolidation test, anywhere else the load application, initial load whatever you are taking, load application always double. That means 25, 50, 100, 200, 400, 800 and 1600, because with this double this load application you are going supposed to get best result. And but what is the reason why I cannot apply 25, 40 or maybe 70 or maybe 110, why it is 25, 50, 100, 200, 400, 800, always it is double. Next question is, generally initial load of 25 kPa has been applied in case of consolidation test, then why, what is necessary to apply initial load of 25 kPa? So, the reason being, if initial load increment is too low, then the excess pore pressure may not be sufficient to initiate pore water flow. The reason being, just I have written for your better understanding, you can write it. The reason being, why this initial load is 25 kPa, why not 10, why not 5, why not 15, why not 30? In general it is standardized, means if this initial load increment is too low, say instead of 25 if you apply 10, if it is too low, then the excess pore pressure may not be sufficient, means whatever excess pore water pressure generated, it may not be sufficient to initiate pore water flow. What will happen? The moment you apply this load, so initial load let us say 10 or 15, you apply, so it's try to compress the soil. Once try to compress the soil, pore water pressure inside the soil sample try to come out through void space. So, it may possible that initially this load is not sufficient, that this pore water will come out. To help that, as per this ASTM standard, it says initial load of 25 kPa is recommended, so that it will initiate, it will start, initiate or start your pore water pressure flow or maybe pore water flow. So, these are the two things you just while doing the test, these are the two things guidelines: initial load increment, initially what is the load you are supposed to apply, 25 kPa minimum, then afterwards you start with 50, 100, 200, 400, 800 and 1600. Then with this application of, suppose you apply a load of 50, suppose you apply a load of 50 kPa. Similarly, as you are increasing your load in double, you can take the measurement of dial reading, displacement or the volume change of the soil dial reading in 1 minute, double it, 2 minute, 4 minute, 6 minute, 8 minute, 15 minute, then 30 minute, then 1 hour, 2 hour, 4 hour, then 8 hour, 16 hour, then go to 24 hour. The way you apply this load just double. Similarly, the reading you have to take it for your consolidation is just double. After the double interval, 1 minute means the next interval time is 2 minute, you apply this load with this application of load with this 2 minute you can record. So, for today's class it will be, I am keeping it here. So, maybe you can think why this has been doubled in both time as well as in load, you can answer me. I will start this next part in the next class. Thank you.